Hello, so in this video I want to talk through how we can work out the mode and the median of grouped data. So remember this data which I've got, I've gone out and I've picked up some conkers and I've measured their diameter. And I've put this into a nice little table. So this is basically saying that 26 conkers had a diameter of between 0 and 2 centimetres, 17 conkers had a diameter of between 3 and 5 centimetres, and so on. So 11 conkers had a diameter of between 6 and 7 centimetres, and 6 conkers had a diameter of between 7 and 10 centimetres. And I want to try and find out the mode, the median of this data. Well, the mode is still nice and easy. Remember that the mode, it represents in data formats really easily, because I just looked at the column which deals with how often, the frequency of how often values come up. So in other words, this column here, and I just look for the highest number. In this case, it's 26. And the 26 corresponds to the interval from 0 to 2 centimetres. So I know immediately that the mode, we sometimes call it the modal class, because the class is just these intervals here. Okay, class is just another word for intervals. So the most common interval, or the modal class, is from the 0 to 2 centimetre class. Okay, so that's nice and easy to work out. Now the median, a little bit more involved, so let me just give you a slightly simpler example, then we'll come back to this first. So we've got a nice simple example now, and I want to just illustrate what this means. So remember what the median actually is. It's looking at the middle value. So to work out the median, we have to look at something called the cumulative frequency first. So we've got 3 here, and then we've got 7 here. So we've got 7 things in total. We have to work out where the middle value actually lies. So we do n plus 1 over 2, n being the total number which we have. So in other words, this is 7 plus 1 over 2. So we're looking at the 8th over 2, which is 4th value. So we're looking at the 4th value. So where does the 4th value actually lie? Well, it lies in this interval here, because this first interval only deals with all the numbers up to 3. Okay, so everything up to the 3rd position, whereas this deals with everything from the 4th to the 7th position. So let me just, okay, so the way which I'm going to illustrate this is by drawing out on a number line, all right? So we've got a number line here. What I'm going to do is I'm just going to put all my values on this number line. So I'm going to have from 0, so I'm going to basically draw from 0 to 10, because I'm going from 0 here to 10 here. So all my values will basically fall between the range 0 to 10. So, okay, and I'm just going to number all of my positions. So I know that the first 3 values from my table, that the first three values will fall between 0 and 6. Now, I have to assume, so I know that the first 3 values, so from 0 to, the first 3 values will fall in this interval here, and the second, the last 4 values will fall between the interval from 6 to 10. Now, I have to assume, because I've got no other information, I just assume that those data points are equally spaced. Okay, those data points are equally spaced. So in other words, these first 3 values that fall between the range of 0 to 6, are equally spaced. So in other words, the first value falls at 0, the last value falls at 6, okay, and then the next value falls at 3. Okay, so those are my 3 values, and they're all equally spaced, right? So actually, I've made a slight mistake, because otherwise I've got an overlap. So I'm going to make this from 7 to 10. Okay, so next interval I'm going to be looking at, these 4 values here are going to be lying in the range from 7 to 10. So I just assume that my first value, okay, falls from there. So maybe if I number this is my first value, this is my second value, this is my third value. I know that my 4th value is going to lie from 7. I know that my last value, my 7th value, is going to lie at 10. And I just assume that the 6th and 7th value are equally spaced within this interval. So I know that 6th and 7th is going to lie here. Okay, so remember what I'm looking for. I am looking for my median, which is my 4th value. So my 4th value lies here. So therefore I know that my median is 7. Okay, so hopefully you've got this in your head. You're basically just going to draw out a number line. Okay, I look at my width on my number line, my class width on my interval. My interval is on my number line. Okay, and I assume that all my values are equally spaced along that width, along that interval. Okay, so going back to my example, which I had before. So first things first, and I'm just going to go through this again. I know I went through it in the last video. I just need to basically correct my interval, my class, because at the moment this is to the nearest centimetre, so it's actually not from 0 to 2. I have to consider my higher and lower bounds of that interval. Okay, and this is a little sneaky thing, it's a little subtle thing which most people forget to do, but it's really, really important. So looking from 0 to 2, what's the highest value that it can have, that I can, my conker can take in order to be included in this interval from 0 to 2, bearing in mind it's rounded to the nearest centimetre. Well, are you happy it could be from 2.5 centimetres? Because anything up to 2.5 centimetres will be rounded into this interval. Okay, and then the next one, 5.5, anything up to 5.5 centimetres will be rounded down to 5. Okay, 7.5 centimetres for the next interval, because anything up to 7.5 will be rounded down, okay, and included in that interval. And then 10.5 for the next one, because anything up to 10.5 will be rounded down and included in that interval. Then I look for my lower interval. Well, what's the lower bound of 0, bearing in mind I'm round to the nearest centimetre? Well, it's 0, because I can't have negative 0.5 centimetres of a conker. Okay, this one is going to be 2.5, because from 2.5 to 3, I'm going to round up, and I'm going to include it in this interval here, so from 3 to 5. And then this one is going to be from 5.5, because anything from 5.5 to 6 can be rounded to 6. And this one's going to be from 6.5 to 7, because anything from 6.5 to 7 is going to be rounded to the 7 interval. Okay. So now what I can do is I can just cross these off, okay? Because I don't want to consider these intervals anymore, so I can get rid of those. So actually, I'm just looking at the interval now. These are my true intervals, if you like, from 0 to 2.5, 2.5 to 5.5, 5.5 to 7.5, 6.5 to 10.5. Okay, so what's the first step? Right, to find the median, I need to look at my cumulative frequency. So let's look at my cumulative frequency now. So I've got 26, then 26 plus 17 is 43, and then 43 plus 11 is 54, and then 54 plus 6 is, 60. So it's 60. So my total number of conkers which I look at, which I end up picking up, is 60 conkers. Okay, so now I'm trying to find the median. I want to find the median of 60 conkers. So remember, I use n plus 1 over 2. So the total number of conkers which I end up with is 60 plus 1 over 2. So I end up with 61 over 2. So I'm going to be looking at the 30.5th value. So where does the 30.5th value lie? So I'm going to be looking on my number line. I'm going to lay all my numbers out on a number line. I'm going to be looking where the 30.5th value is going to lie. Well, actually, I can make a little bit of a shortcut, because I'm not going to bother writing out, I'm not going to bother drawing out all the intervals on the number line of the first 26 or the 54 or those final ones up to 60. Okay, because I know that the 30.5th value is going to lie in this interval here, because the first interval only looks up to the 26th value. The second interval looks up to the 43rd value. So the 30.5th value lies between 26 and 4.3. So I know then that the median must lie within this interval from 2.5 to 5.5. So let me draw that out on a graph. On a number line. So, okay, I know, so this is my two bounds out, so this is basically my interval. I know that my 26th value, must lie at the 2.5 point, because you look here, okay, the lower interval ends at 2.5, okay, so therefore the 26th value must lie at 2.5. Okay. Likewise, I know that the 43rd value must lie at the upper bound of that interval, which is 5.5. So, okay, well, how many points, how many values do I have between 2.5 and 5.5? Well, I have 17 values. 17 values, because 26th value starts at 2.5. 43rd value is at 5.5, so within the range from 2.5 to 5.5, I must have 17 values. And you can see that from the table up here. Okay, so in other words, I need to now work out, I assume that all those 17 data points are equally spread between that interval. So I now need to work out where my 30.5th value lies. But first I need to work out, well, how much is that? So let's just assume I've drawn 17 data points in there. How much is that little interval there? So how much is one step between the 26th and 27th value worth? And that's going to be the same as between the 27th and the 28th value. Okay, so how much is that worth? Well, I know the overall width of that interval. Is, well, 5.5 minus 2.5, right? That's the overall width of that interval. Okay, so that comes out as 3. Okay, and I'm fitting 17 points. Within that interval. So it's 3, and I'm dividing it into 17 equal parts. Okay, so I end up with 3/17. So each one of these intervals here, so that interval there is worth 3/17. That interval there is worth 3/17. That interval there is worth 3/17. Just assume there's 17 points in there. Okay. So I'm looking for the 30.5th value. So there's 27, there's 28, there's 29, there's 30, there's 31. So I know that the 30.5th value, the one which I'm after, 30.5th value, so I'll get rid of that now. The 30.5th value must lie halfway between the 30th and the 31st value. So I've got each one of these intervals is worth 3/17. Each one of those intervals worth 3/17. 3/17. So I start at 2.5. I move 3/17. So I've got 2.5 plus 3/17. Then I add another 3/17. Then I add another 3/17. Then I add another 3/17. But in order to get the 30.5th value, I'm going to have to move half of 3/17. So how much is 3/17 as a fraction, roughly? So 3/17 a fraction is worth about 0. Horrible number. It's approximately 0.18. Okay, so half of that. It's even worse. That comes out as approximately 0.09. Okay, so 0.09. So in other words, I'm going to have to move how many 3/17? I'm going to have to move 4 3/17. So my 30.5th value, let me move this up. So my 30.5th value is going to be equal to 2.5, that's where I start with. I then move 4, so I then move 4 3/17 intervals. Okay, so 4 times 3/17, 4 times 3/17. So I've got 3/17 plus 3/17 plus 3/17 plus 3/17 plus 3/17. That gets me to my 30th value. Okay, but then I'm going to have to move half of one of those tiny little intervals, half of one of those 3/17 intervals, to get to my 30.5th value. So then I'm going to have to move the 0.9. So sorry, 0.09. So when I evaluate all that, I end up with 2.5 plus, what's 4 times 17? So that's 12 over 17 plus 0.09. I'm just going to stick all that in my calculator. So plus 12 over 17 plus 0.09 is equal to, horrible number, but okay, 3.3. Let's call it. So my 30.5th value lies at 3.3, which makes sense because if we get rid of all these annotations, my 30.5th value should lie roughly between 2.5 and 5.5, probably about a third of the way through that interval. So that actually ends up lying at 3.3. So that's my median value. It's a lot of work, but hopefully if you can visualize what's going on, just draw your number line, assume that it's called linear interpolation. It's basically assuming that all of those data points are equally spaced in that interval. Okay, and then you can work out from there the 30.5th value.